Question 7 is showing us a method of finding the sum of counting numbers. That's shown here, where we write the numbers forward and then backward, and then add up in columns to get a nice expression for our answer. So the question is asking us in part A to use this method to explain why adding up the numbers from 1 to n can be expressed by this formula here. So let's just start by writing out those numbers forward. So we're going to have 1 plus 2 plus 3 plus all that stuff in the middle. And then at the end, we're going to have our last three numbers are n minus 2 because it's 2 away from the last number n, plus n minus 1 plus n, which is our last number. And this is going to equal some answer, which I'm going to just call A. So now we want to write those series backwards. So we're going to have the last number here, n plus n minus 1 plus n minus 2 plus all that stuff in the middle. Then we're going to have 3 plus 2 plus 1 on this side. And that's again going to equal our answer A. So what we want to do is add up all this stuff in columns. So on this first end, we're going to have n plus 1. And then here, if we add up 2 and n minus 1, we're taking n, we're subtracting 1, but we're adding 2. So in the end, we're going to get n plus 1 again. You can see here, if we add 3 and n minus 2, we're subtracting 2, but this time we're adding 3. So that gives us n plus 1 again. Then we have all this stuff in the middle, and on this side, we're going to get the same thing. We're going to get n plus 1 plus n plus 1 plus n plus 1. And on this side, if we add one A and another A, we get two A's. So if we look at what we have here, we have a bunch of n plus 1s. And if we think about how many n plus 1s we have, we're adding all these things in columns. So the number of columns we have is equal to our top number n. So we're going to have n number of n plus 1s. And that's the same as saying we have n times n plus 1. And this is going to equal, on the right side of our equation, 2 times our answer. So if we want to get what just our answer is, we have to divide both sides by 2. And this gives us that our answer, or A, is equal to n times n plus 1 over 2. And that's the formula that we get. So in part B of question 7, they're asking us to use this method to evaluate this sum of numbers here, which is 4 plus 7 plus 10, all the way up to plus 217. So we're going to do the same thing. It's part B. And we're going to write out these numbers forward. So I'm just going to write the first three numbers of this sum, which is 4 plus 7 plus 10. Then I have all this stuff in the middle. Then I have plus 211, 214, and 217. This is all going to equal some answer that we want to find, or A. And I'm going to write these numbers backwards. So I have 217 here, 214, 211, all the stuff in the middle, and I get plus 10, plus 7, and plus 4 equals our answer. So again, I'm just going to add this up in columns. 217 plus 4 is going to equal 221. 214 plus 7 is going to equal 221. 211 plus 10 is equal to 221 again. And we can see the pattern here. We're going to get the same thing on this side. 221 plus 221 plus 221. This is all going to equal 2 times our answer. So we can see the pattern here. We've got a bunch of 221s that we're adding together. But the tricky part here is figuring out how many numbers we're adding together. So how many 221s? And it's maybe not quite easy to see from the original sum because we are skipping 3 every time we're going to the next number. So we're adding 4 and 7 and 10. We're skipping 3 each time. So the answer solutions for this problem gave one way of figuring out how many numbers we're adding up, and that's by seeing that there's a pattern where to get the first number 4, what we've done is we're taking 3, our gap, times 1, and we're adding 1. To get our second number, 7, we take 3 times 2, and then we add 1. So to get our last number, 217, this is, if we want to add 1, it's going to be given by 3 times 72. And so you can work that out algebraically, and this means that we have 72 terms in total. Another way you can figure out how many terms you have is to figure out the difference between, let's say, from 4 to 13. So take 13 minus 4 and divide that by 3, which is our gap. This is going to give us how many terms we've added to 4, our first number. So if we do 13 minus 4 is 9, divided by 3 is 3. So this means that we've added 3 terms to our 4, to the first number, which is 4. And so if we want to find out how many terms we've added to get 217, we just do the same thing. We do 217 minus the first term, which is 4, divided by 3, and that gives us 213 over 3, which is equal to 71. So that means we've added 71 terms to 4 to get 217. So our total number of terms is 71 plus 1 more for the 4, so it's 72. So this is just 2 ways of getting the answer that we have 72 columns that we're adding up in each of these cases. And so that is something we need, because what we're going to do is we're going to say we have 72 times our 221 that's appearing here, and that's going to be equal to our 2a over here. And so to get our answer, or a by itself, we're going to divide both sides of this by 2. So we get a is equal to 72 times 221 over 2, which is equal to, if we evaluate it out, 7,956. So for part B, evaluating the sum of numbers, our answer is 7,956. Part C is asking us to prove that the sum of n evenly spaced numbers equals half of n times the sum of the first and the last number. So a more general way of writing this sum of n evenly spaced numbers is to say that we're going to say our first number is something a plus k. That's going to be our first number. And then for our second number, what we do is we take 2 times k, which is whatever our spacing is between each of our terms. And so our second term is going to be just a plus 2k. And if we continue this on, we're going to have 3 times the amount of spacing in our third term. So it's going to be 3k, and that's how we get all these terms with evenly spacing, even though we don't know what the spacing is. And so this is going to continue until our last term, where we get a plus n, whatever our last number of terms, n is our number of terms in total, and we're going to have n times our equal spacing of k. So the sum of all this is going to give us our answer a. We want to show that we can express this sum as half of n times the sum of our first and our last number. So to see how we can do this, we're going to use our same method and write this sum out backwards. So we're going to put our last term at the front. So we're going to have a plus nk up at the front. And we're going to write out our terms, our sum backwards, but I'm just going to skip that for now and skip down to our last term, which is going to be a plus k. This again is going to equal our answer. So you want to add this up in columns, and we can see what we're going to get is a plus k plus a plus nk here. And we know from our previous questions that this pattern is going to continue, and we're going to get the same thing over and over until our last term. It's going to be the same thing, a plus k plus a plus nk. And that's all going to equal 2 times our answer. And so we know that the number of times we have this thing here is going to be equal to n. So we can express this as n, our number of terms, times a plus k plus a plus nk. And this is all equal to 2 times our answer. So if we want to get our answer by itself, I'm going to divide both sides by 2. This gives us our answer. A is equal to this thing where we can take this dividing by 2 and express that as 1/2 times n. That's the same thing. And then we're still going to multiply this 1/2 n times a plus k plus a plus nk. And so if we look at what we've written here, we've said that the sum of this series, or answer, is going to be equal to 1/2 times n times the sum of our first term, which is a plus k, and our last term, which is a plus nk. So that's the same way that the question's worded in part C, and so we have proven this.